Hello, my name is Venkat. What platform is the best one for future among the three? AI, DL, ML. Basically, these are interrelated. If you ask me which is the most exciting among all these three, basically deep learning is the one with computer vision and a lot of driverless cars and pilotless aircraft. All these things, most of the research is happening in deep learning. These are all interrelated. We'll see those things. So basically, what is artificial intelligence? It is kind of mimicking human intelligence. Long back, we had computers, and Alan Turing is the first one who proposed that instead of computers following dutifully what it is told in form of a program, they should think on their own. So that is basically where this research has started. It is more than 50-year-old research. Now it became prominence because of all the other advances like big data and cheap memory and all the processing power that we have, GPUs and TPUs, all these things, and the availability of humongous data with social networks and all. Now we have too much data. We are producing more data in a day in this century than we produced for first 16 centuries of this millennium. So that much data we are producing. In a day, what we are producing is a humongous amount of data. That's why we need data for these things. Artificial intelligence, data is the fuel. So we have the data, we have the processing power, and that's why this technology came to fruition now. Okay, since 50s, it is how that is progressed. Then machine learning is basically a subset of artificial intelligence. Basically, machine learning is the field that have algorithms that learn from the experience and from the data. We'll look into use cases and all those things, but machine learning is basically a subset of artificial intelligence. In that one, recently, in the last 10, 15 years, deep learning became a humongous growth technology. So deep learning is basically again a subset of machine learning, but this one is using neural networks. Okay, that's why the learning will be deep. That's why it is called deep learning, artificial neural networks. That is the latest technology. So that is how these are interrelated. So when you are working in deep learning, that means you are working in artificial intelligence, and the subfield is basically the deep learning. Same thing applies to machine learning. So what is artificial intelligence? Artificial intelligence is basically, as I said, that it is kind of mimicking human brain, just thinking on its own and taking decisions on its own and making predictions just like a human, knowledgeable human predicts about things. An experienced person predicts about these things. One example is if the car goes into an accident and the car owner shows it to a experienced garage mechanic and say that, okay, how much it takes to repair this car? Garage mechanic with his experience will give a figure, maybe $3,500 it costs to repair this because these are 7 parts are damaged. So each part approximately costs this much. That is based on his experience, he'll predict that the artificial intelligence products are doing now. So how they do, you take the pictures of the accidental car and the models will look into those images and look at the damages, and based on the experience, based on the learning, just like a experienced mechanic, the models say that, okay, this is how much it costs. And it saves a lot of time. Previously, it used to take 2 to 3 days for the car to go to a garage and then get a mechanic to get the estimate and all. Now, this artificial intelligence products can give the estimate in a couple of minutes. Like that, in every sphere of the world, artificial intelligence is making life-changing decisions and all. So that is what artificial intelligence is. Basically, it is mimicking human intelligence. That's all it is. This is long back started with a paper proposal for the Dartmouth summer research project on artificial intelligence. This happened in 1955 with collaboration from IBM, Harvard, Bell Labs, and Dartmouth College and all. So it is not a new technology, but it came to prominence in the last 15 to 20 years. Just basically, as I said, in 1950, Alan Turing proposed a Turing test as a measure of machine intelligence that is still used today to determine the machine's ability to think like a human. Okay, so instead of doing instruction by instruction, going through a program, basically this is giving the thinking ability to machines. That's where that's what the game changer is. If you go look at the history, okay, mechanical men and artificial things appear in Greek myths such as golden robots of Hephaestus, Pygmalion, Galatea. There are mythological references to the artificial intelligence. Even in the Middle Ages, there are rumors of basically alchemy and placing mind into matter, all those things. Okay, so those basically, this is kind of not a new idea because it has roots in even mythology and deep, long back history too. Okay, so just a few use cases of artificial intelligence, basically AI for good. AI address socially relevant problems such as homelessness and other social aspects of the society. Basically, it has application in every sphere. Here, some of the cases like aviation, lot of applications in aviation, including the pilotless aircraft that is being tested in United States this year. So there are a lot of applications in education, lot of automatons or robots, okay, trying to teach subjects. In every aspect, there are applications now. Even they created a robot that has written a script for a movie. Even it is coming to the arts, where we think that like movie script writing and all, we thought like writing a poetry or anything, we thought like this is human realm maybe 10 years ago. Now the artificial intelligence is doing a good job in that too. There is one movie that got an award in UK, and later they realized that the script was written by a robot. Okay, the applications are immense in healthcare, heavy industry, and finance. Lot of applications. Before giving a loan, the banks are now using artificial intelligence models to assess the risk and to check the fraud, and lot of even for predicting stock market, hundreds of mutual fund companies and all, they are using artificial intelligence products to predict stock market on each and every day. If you go search on the web, there are people who made billions in predicting the stock market. There are use cases. The Stanford University, there is a paper that predicted Google stock price about 7-8 years ago, and the predictions came very close. Okay, let us go to some more use cases. As I said, there are a lot of use cases in this one. We can go on hours and hours talking about. There isn't any field in the world today that is not touched by the artificial intelligence application. There are game playing robots. There is a robot that beat the world champion in Jeopardy. It's a quiz show in US, and you saw that the intelligent Watson beating the world champion in game of chess and in game of Go, and almost everywhere. Now, no human can beat basically artificial intelligent agent, okay, in the game of chess, even not even the world champion. That is kind of the amazing advance that world has seen in the last 15 years. So some of the applications, again, car can easily recognize road marking signs and traffic lights. This is very close to market. This one, Google has made tremendous advances in this one. Tesla, Google, and all other companies. Now, the driverless cars have traveled millions of miles without accident, and technology is so close to be on the road now for humans use. We'll go over the evolution, artificial intelligence, machine learning we'll go over, then we'll go to the deep learning, which is where the most of the interesting research in the world is happening around. So what is machine learning? Machine learning is a type of artificial intelligence that provides computers with the ability to learn without being explicitly programmed. So basically how we learn, okay, how humans learn, that's how the machines learn. We'll see that how it happens here. You see that all the applications in the world, from the Facebook to everywhere, they recognize faces. All these applications are everywhere. How they recognize the faces and all those things, we'll see those things. So what are the steps involved in machine learning? First of all, as I said, data is the fuel for all this artificial intelligence. Without data, there would not be any artificial intelligence. The more data we have, the better thinking these things. Basically, the more preparation you have, the better you do it in exam. Same way, I mean, you are learning from the book, the machines learn from the data. That's all it is. Then cleaning the data. That means data should be of highest quality. And then analyze the data, then train the algorithm, test the algorithm, and use it. These are the steps that are involved in machine learning. So how a problem is solved in using ML? Okay. So there are basically few types of algorithms. Okay. So first is a classification. What is classification means? You say that this is true or false, or the person has cancer or no cancer. Okay. The person has diabetes or not diabetes. This email is spam or not spam. Even for emails also, we are using artificial intelligence now. Google uses, every company uses artificial intelligence for everything. Even when somebody sends you a mail, so it goes through the algorithm to see if the mail is a spam or not. These are called classification algorithms because they classify into certain classes. Here, if for the mail, the two classes are whether it is a spam or not spam. So two class classification. Maybe when the car goes into accident and the artificial intelligence product looks at each part and say that, okay, there is a three-way classification. That means part is good, it is not at all damaged, and the part is damaged, but it can be repaired. The third class is it is damaged beyond repair. That means it has to be replaced. There it is a three-way classification. For some, maybe it could be five-way classification. Okay, if you want to recognize a digit, whether it is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, then it is a 10-way classification. If you want to predict a grade of a student in US grading system, it is A, B, C, D, F. That is a five-way classification. So basically, classification is you just classify into some finite number of classes. That's what classification is. Then there are other type of algorithms, other type of applications, that is anomaly detection. That means credit card fraud, all the fraud detection, basically to see that there is something wrong, that is unusual, weird thing happened. Okay, suppose like how the algorithms work there. We'll have a huge history data about your habits, basically how you use, how much credit card you used or debit card you used in the last 5 years, what are the types of purchases you did, all those things. And if there is any unusual thing, basically unusual means your purchases are generally from maybe $10 to $100 on average. That's all your purchases. Suddenly a $3,000 purchase is there. Generally you purchase during the daytime, between 10 o'clock in the morning to 5 o'clock in the evening, and this purchase happened at midnight. And you live in Dallas, Texas, and this purchase happened in maybe Baku or some other city in some other continent. That is also unusual, weird thing. So then they will flag this one as probable fraud transaction. How AI algorithms knows about this? Basically, they look into all the data and they think that this is unusual thing happened, because this is not like what is usual, your buying habit or your spending history. That's how the anomaly detection at a very brief level. There are so many things to it, but at a very brief level. Okay. Then there is other kind of algorithms. Those are called regression algorithms. Regression algorithm is basically classifying. We classified into this thing. Sometimes you need to predict a continuous number. That means not just a class, maybe a stock price. You cannot say that tomorrow's stock price of Google will be within this range. We don't know. So that is a continuous number prediction. That means If it is $80 now today, it could be $81.25. It could be $90.44. We don't know. Okay, we cannot say that it will be in these 10 range classes. No, that is called regression. When the prediction is basically a continuous number. Those are weather prediction. There are several things that we predict. Okay, those are called regression algorithms. Then there are something called clustering algorithms. What is clustering is basically looking at into data and classifying it or clustering it so that, okay, this is one group of people, they all behave in some similar way. There is another group. It could be people, it could be anything. Basically, we are forming groups based on some characteristics. That's what clustering is. Then reinforcement. This is what somebody asked question, that what is reinforcement? Basically, reinforcement is kind of carrot stick kind of approach. You're asking some questions. I'll just answer those things once we complete this one. What is reinforcement learning? Reinforcement learning is basically, we talked about that IBM Watson, that is built on reinforcement learning. Reinforcement learning is basically carrot and stick. That means the machine will learn on its own. All we do is we'll give a feedback saying that this is good, this is not good. Just like training a kind of puppy. When you get a puppy, new puppy, basically you train the puppy is basically, if it goes pee inside the house, then you scold the puppy. When it goes out and pees, then you say that, you give a cookie or biscuit, saying that, okay, that's good behavior. So basically, when you reward good behavior and when you penalize bad behavior, you are teaching the system that, okay, this is the good thing to do it, this is what not the good thing. That's how that IBM machines learn chess also. Basically, if there is a good move, then it was told that this is awesome, you are getting a reward. If it is a bad move, then it was penalized, saying that this is not good move. Initially, even just city level players used to beat that chess playing computer. Later, it learned so much that it even grandmasters could beat it. Later, it learned so much that even the world champion could not. Because this is all called active learning. Active learning is learning from your own game. What steps I did that made me lose this game? What steps I did that made me to win this game? This is what happens in that machine that beat Jeopardy champion or the IBM Watson, AlphaGo. All this is reinforcement learning. That means learn from the past experience. Okay, that's how those machines learn. How commerce student can come into AI field? So basically, AI field is kind of multidisciplinary. That means anybody can come as long as you are passionate about it. You should have the burning passion. That's what the prerequisite is, in my opinion. Okay, if you have that burning desire, you can learn all these things. You need to learn algorithms and you need to learn a programming language. Mostly it is Python. Most of the world uses Python now, because Python is the language that we need to use to teach these computers basically. You don't need to write much code. Most of the code is written in the forms of libraries. All you need to do is get that code, import that code, and there is a slight customization that you need to do. For that, you need to know a programming language. Most of the companies now are using Python. There are companies that use a language called R, that is also being used. Okay, especially some universities are using R programming language, but there are companies also. But most of the companies now are shifted to Python, because all the giants like Google and all other companies made Python as their de facto programming language, because it is easy and there are many people available. 100,000 libraries are available, and it is fast and it is easy to learn. And most of the universities are now teaching Python as an introduction to computer science. So all these things made Python the most popular language. Let us see what are the types of ML, machine learning. There are basically three major types of machine learning. One is called supervised machine learning. Second one is called unsupervised machine learning. Third one is called reinforcement machine learning. Most of the work in the world today is in the supervised machine learning. Okay. So what is this supervised machine learning? Supervised machine learning is basically the machines. There are several algorithms, whether it is decision tree, random forest, naive Bayes, 𝐀𝐛. 𝐀𝐛 stands for K nearest neighbor. Okay, logistic regression, support vector machines. There are a lot of algorithms. All algorithms is basically is like these are several ways to teach the computer basically. How this machine learning teaches the computer or makes the computer learn through supervised learning is just like how a teacher teaches in a class. That's how it is basically. That means you have to teach by example. That means, okay, suppose you are teaching about the weather prediction. Think that there will be around 100 or so features that will affect the weather, like humidity, the temperature. There are hundreds, I think there are 600 or 700 factors that affect weather at any given point of time. So these are all called features in machine learning. That means these are the things will decide the weather condition at that particular moment for that particular place. Okay, how we teach that to the system or the computer is basically giving huge amount of data, that whether from maybe 100 years, for 100 years, what are all the weather conditions, hour by hour, you teach, give it to them and say that this is how the result is. You have these 600 factors and it trained on that moment. These 600 factors and this is the temperature at that. So basically, you are saying that you are teaching the computer by example. That's how the teacher teaches in a class, right? That is why it is called supervised learning. All these features, and at the end, there is one thing called label or a target. Some people call it label, some people call it target. This label or target is the result. So you say that this is the temperature, this is the humidity, this is the atmospheric pressure, this is the wind direction, this is the wind velocity, all these features. And the result is it rained. All these things, the result is it did not rain. All these things, like that, you give the billions of records, billions of data. Then basically this is how the computer learns. It will take all these things and learns, okay, these are the conditions, this is how the weather will be at that time. These are all the conditions, this is how it will be. So this is called the supervised learning. Basically, supervised learning, you will train the computer with lot of basically question kind of an answer session. This is the question, this is the answer we got at the time. Then you will test it with the questions, the new questions, and there is no answer for that, and make the computer predict that one. And you tell the computer this is how much the prediction came correct or not. Okay, so that is what the supervised machine learning is. The unsupervised learning, basically, it's not like this one, not like with the question answer kind of setting. Unsupervised learning is basically you give the entire amount of data and ask the computer to figure out the patterns in this one. So basically, the algorithms there will see the data, will do lot of computations. Basically, all what is happening behind these algorithms is they will do billions of calculations in using matrices mostly, and billions of calculations using linear algebra, Fourier transforms, do lot of math. Basically, this is all math behind the screens. If you see the processing for each second, it will do billions of calculations, and some of these algorithms will run for weeks. That means you can see that how many hundreds or thousands of billions of calculations is going on behind this. Okay, so that is unsupervised. And reinforcement is, as I said, basically it is punishment reward kind of system. Okay, that system learns from its own rules and its own reward kind of system. So what are the limitations of machine learning? Okay, machine learning algorithms are not useful while working with the high dimension data. That is large amount of data. If you have humongous amount of data, Then the shortcoming of machine learning is it takes a lot of time. Sometimes it takes too much time. Those are the some of the shortcomings basically, and these cannot solve crucial AI problems like natural language processing, image recognition, all those things the machine learning cannot do, because machine learning basically doesn't know how to look at the image or a video or a audio. Basically, it knows how to look at the data, that is numbers, and it can do all the calculations on the numbers. But if you want to see the driverless car, the car has to see. There, the machine has to look at the road and recognize the road signs and recognize anybody crossing the road, all other cars. All these things requires vision that is lacking in machine learning. That is the reason that basically deep learning came into prominence, because deep learning works on all these, the videos, the audio, the images. Okay, this is basically called unstructured data. So machine learning works on structured data like your tables, Excel sheets, all that kind of structured data where you collect all the data and train that models. But if it comes to images or sounds or speech or video, then machine learning cannot handle that. That's the reason that deep learning came to the rescue. That means then they thought about, okay, without the vision, there is, because human, five senses for the human are the most important one is the vision. So without vision, basically these applications, many applications cannot be fulfilled. Like good example is basically, as I said, accident, car went into accident, you need to assess the damage. Without looking at the images, how the humans assess? Basically, they look at the car and they assess the damage. So if the computer cannot have the vision, then they cannot. Same thing with the driverless car or pilotless aircraft or many of the applications. If you cannot see, then you cannot do. So that's the reason that deep learning came into picture. Deep learning can look at the images and understand how the deep learning works. Basically, the deep learning is designed based on neural networks. How our brain works, this is how the research is done. How our brain works, the image that goes from our eye into our neurons. Basically, neuron is a basic processing unit in our brain. So as you can see in the slide, there are billions of neurons in human brain, billions literally. Okay, and they form kind of network. Each 7 to 10,000 of neurons will connect to each other to do some small task. That's what the neurologist found out, and then that is what the imitated. That's what imitated by using our computers to work like brain. So what is this neuron? Basically, neuron is the basic processing unit. Okay, if you see an image, several networks of neurons will get activated and will identify what that image is. So a neuron will have mainly three types of parts. One is basically the dendrites. Dendrites are small thread-like things that connect one neuron to the other. So this is how the signal is passed from our senses to all the way to the brain. And those dendrites are basically the thread-like things you see. And then there will be a nucleus, cell body, and inside the cell body there is a nucleus. Okay, that's where all the processing will be done in each of the nucleus of the neuron. As I said, we'll have billions and they form millions of networks, and one network can have 7 to 10,000 neurons. That is what just we imitated in our artificial intelligence. So once the signal is collected by the neuron, it is processed inside this nucleus and then it is passed through this axon. This is how it works. So basically what happens is the signal comes to the nucleus, and there all the signals that came to the nucleus through various dendrites, it is basically processed, means it is basically summed up. All the signals are added and see the threshold is exceeded or not. It is basically like a switch. Okay, this much current we got from various resources. Does it cross a threshold? Shall we turn the switch on or no? No need to. So that is the decision that happens in the nucleus. If all the signals together cross the threshold, then the signal is passed to the next neuron. That's how this network will work. The same thing is copied, and we built the perceptron with the same network that we used, and same nucleus is copied here, same outputs, same inputs. Whatever the inputs that you see here, these are all the dendrites in that neuron. So whatever the blue box you saw, that one, that is basically the nucleus. So whatever you see that function y here, that is what the threshold is. If it is beyond that threshold, the output will be given. That is what the artificial network, exact copy of what our brain is. So why neural network? Because that's how brain works. That's how anybody can think and anybody can make a decision. Basically, humans got the decision making capacity and learning capacity because our brain. So that's what we imitated basically. The computer follows a set of instructions in order to solve a problem. That's what we learn things basically. Humans learn things. Let me give you an example. So suppose you see a small kid, okay? You have a small kid and the kid is maybe just a few 1 year old or something. The kid has never seen a dog, okay, in his life. So the parent first time in the life of the kid shows a animal, a dog, then tells that, oh, this is a dog. What happens is basically, since the kid has never seen the dog, he sees the dog and he gets a features of the dog. Okay, how it looks, how many legs it has. It has a tail. It has kind of hair. It has these ears, pointy ears. This brain gets the high level features of that, and all these features. Okay, then the brain will learn that, oh, if you have this kind of features, this is a dog. Parent will show one other dog maybe at a later point, maybe which is kind of different. Maybe first he will show a Chihuahua, there later he will show Alsatian or a bigger dog. Then it tells that it is a dog. Then this kid's brain, okay, will learn more. Okay, the dogs can be this size also. Okay, can have this kind of color also. This there are some features that are there in the initial image that person saw, but it can also be like that. This is how a kid learns. If you show 3 4 dogs, that's all it is required for a kid. To next time if you show a new dog, kid remembers that, oh, this is a dog, because the networks in his brain learn based on the features, how a dog looks like. All those features, the eyes, the ears, the 4 legs, all those things, the human brains learn like this. Same thing happens in neural networks also. Here also, the network will see an image, extract features, and the only problem here is, for the kid we tell only, we show 3 4 dogs and tell them that these are dogs. That's enough for the kid to name any dog as a dog, even in the entire life. Only problem with neural networks is you need to show thousands and thousands of images of dog to teach the computer to identify a dog next time you show a picture. That is the only shortcoming for the neural network. That means it requires much more training than a human brain, much more data. The more data, the better it learns. So if you show 100,000 images of dogs in various settings, various breeds, various colors, various postures, okay, you show 100,000, then 99.99% it will recognize any dog image if you show that after that, because it learns about all kinds of features. Some dogs, Chihuahua is very tiny dog. Then Great Dane is very big dog. Some dogs have pointy ears. Some dogs are different kinds of hair. Some dogs, all kinds of different breeds of dogs. Computers learn like that one. This is how the neural networks learn. Basically, they extract the features, and this is all. The image of dog will be broken into basically vectors. That's behind the screens. How it happens is it will be broken into vectors. That means the image will be broken into a huge set of numbers, and all these numbers is basically all the features, and these are all the input. Here you see that x1, x2, xn, it could be millions input, all the features as numbers only. So each pixel basically in an image become like a input kind of uh, vector and can be given as an input. And in this blue box here, this is where the processing will happen. Okay, in a network you will have huge number of neurons, millions and millions, just like our brain, and all the signals that is coming. Suppose you have a minor feature like a nail of a dog, which is not much important. Even human brain also doesn't look at the nails and all. That is a minor feature, so that won't be fired. That's where it won't cross the threshold. Only the major features will cross the threshold. That's how human neuron works. That's how the artificial neuron is working. Okay, so basically in the training you show that thousands and thousands of image, anything you show. Suppose for a driverless car you need to show stop sign, you need to show millions stop signs in various colors, various fonts, various ways. Something this tilted, that tilted. You need to show huge amount of data so that it learns in any kind of circumstance. So what is this activation function? As I said, you need to have a threshold. If it crosses the threshold, the signal has to cross from one neuron to the other. How it is, this activation function is the one that decides whether the signal is strong enough to pass it to the next one. Means whether the feature is strong enough to be learned. Okay, is it a ear, important feature, a part of the ear, a small chunk of a nose or something, then it will pass. It is unnecessary feature, then it won't pass. Some noise, okay, suppose the dog is on a lawn and the part you see is maybe a part of a small leaf, that is not required, that won't be passed through. Okay, so that's what these activation functions are. Okay, so as we said, like we'll talk about Perceptron is basically a simplest neural network. Simplest means the basic neural network. Okay, in the actual architectures, you will have millions of neurons at hundreds of layers, all those things. But the basic unit is the perceptron. Just like the basic unit in our brain is neuron, because we'll have billions of neurons. Okay, so suppose you want to go to a beer festival, just a small example here. You want to go to a beer festival near your house. So your decision depends on whether to go to the festival or not. It depends on how is the weather, your wife is going with you or not, or any public transportation is available or not. So basically, these are the features we are talking about for the decision. So if the weather is good, you will go. Otherwise, you will not go. Okay, that is the feature that is deciding. If your wife is going, you want to go. Otherwise, you won't go. Transportation is available, you will go. Otherwise, you won't go. These are kind of factors that are called the features. So if the output is beyond the threshold, that means here the decision is basically yes or no, whether you are going or staying home. Okay, if the threshold crosses all these three decisions, whatever the factors you have, the threshold crosses a certain threshold, the signal crosses, then you go. That's what the decision is. So that is what features and all these things. Then weights, basically. This is what, if you want me to name two words in artificial intelligence, okay, that the most important. Those two words are data, which is fuel to artificial intelligence, and weights, which is the output of all the learning. So basically, if something is learned about everything, okay, all the images in the world, then what you think is the output is basically it is all a huge array of numbers, huge billions and billions of numbers that are called weights. That is what the entire learning is. Basically, all the learning is in the form of weights. What are these weights? See, if your decision to go to that beer festival is mostly dependent on whether you give that more weightage to that decision, then it has more weight. If you weather is not that much for you, it is will be given less weight. In the dog example, I said the nail is not a good feature, not important feature. It will be given the least weight for that. But the iris of the dog is most important, and the hair, maybe nose, eyes. These are all the most important features to identify dog. That those will be given the highest weight. The learning is basically, this is a neural network. Okay, so basically the first layer you see, that is called input layer. That's where all the image data is fed into. Then all the hidden layers slowly extract all the features layer by layer. Okay, and the final decision output is basically, it will say whether the picture is of dog or not. That's what the output is. Again, training the neural network is basically, training the neural network means finding the right set of weights for all the features. That's all it is. In one sentence, the heart of artificial intelligence, deep learning, everything, the heart of it is, in one sentence, if you ask me to tell, it is adjusting the weights. That is what it will be doing. All the millions of computers in the world, GPUs, high-end computers, all those things, they are working day and night to figure out the right set of weights. That's all it is. The entire work in that world is basically adjusting the weight. How they will adjust the weight? They will see the input, they know the desired output. Okay, they see that whether how much far away we are from the desired output. Okay, this is the input, this is the output we are expecting, but we did not get that output. That means always there will be error. So how much error we got is basically how much we differed from the input, and then we have the weight. So the weight basically gets multiplied with the features, and then we'll come back in. That's how basically the network learn, always predicting something and then seeing how much error we got, then adjusting the weights and going back and again calculating. It's going back and forth millions of times. This is what the learning is. Okay, did I say correct? No. Okay, how much error I got? Okay, this much. Let me adjust my weights. I'll do this again. Let me adjust my weights. I'll do this again. This is what it is called training. It will be done in steps called epochs. Okay, you run 1,000 epochs means you see the entire data to the show the entire set of images, videos, or to the algorithm, and then decide that how much close you are to the actual result. Then do it again. Then do it again. That is, people do it for thousands of epochs. That's why these algorithms take sometimes weeks and weeks on high-end machines to run to learn these things. So basically, adjusting his weights is basically is the crucial central point to this training. That's how these computers learn. Okay, how the number of hidden layers is decided. These are all the things. That's what the beauty of this field is. There is no book that will say that the hidden layers should be 500 or 100 or 5. No. Okay, long back, about 7-8 years ago, hidden layers used to be 5, mostly 2, 3, or 5, at most 10. But now we have so much computing power that now there are so many places where we use hundreds of hidden layers, because we have lot of processing power. The more the hidden layers, the more the number of hidden layers, it is called a deep network. Okay, so sometimes to learn all the lot of features in everything, we need deep networks. That's why it is called deep learning. Which one has more scope among these three? As I said, deep learning is the most advanced now, because so many applications have neural networks. Because neural networks are fast, learn easy, and do complicated things. That's the reason that neural networks are very popular now. In all these three, neural networks has more applications now. Okay, but anyway, as I said, these are all interrelated. If you are using deep learning, that means you're using artificial intelligence because it's a part of artificial intelligence. Thank you all. Have a good day.